Hello everybody, welcome again to the ETABS and SAFE course. Now we will begin for the first time with the SAFE software. And SAFE, as we said again, we will check the deflection of the slabs, we design the slabs and beams, and we'll design the foundations. Now we will begin with the checking of the deflection. First of all, we want to export the model from the ETABS file to SAFE. So to do that, we go to File, Export, Story as SAFE V12. Here this windows tell us what story to export, what story we need to export. If we need to do the design of the foundation, we will export the base story with export floor and loads from above. So if we need to design the foundation of the building, we export the base story with export with this option, export floor, loads and loads from above. If we need to design the slabs or the beam, we check this option, export floor loads only, and we will select the slabs or the story of the slab that we need to design. So let's begin with story 1 with waffle slab type 1. So we select the story 1 with export floor loads only. Also we will select the loads that we need to export to SAFE. We select to design slabs and beams, we select only dead load and live load. So we press OK, then here we press OK. We want to save, let's name it So now ETABS export the file. When we terminating from exporting, we minimize after. We open the SAFE. The SAFE is something like the ETABS software because are two CSI software. So as the ETABS, we go to File, New Model. We check the ACI that we have ACI code, and for units we select metric default units. Then we press OK. Here when we want to export from ETABS to SAFE, we select here blank initial model. So now we are on the home page to begin the work on the SAFE. Now we want to check the deflection of the waffle slab type 1. So we want to import the ETABS file. So we go to File, Import, SAFE F2K. We go when we have saved the ETABS file, and we select the file ETABS. Now we have exporting and importing the story 1 waffle slab type 1 from ETABS to SAFE. Now we want to know what is the allowable deflection for this story. We go to the ETABS, to the AutoCAD file, we go to any plane of this shopper drawing. We need to show what is the maximum span between column, what is and where is the maximum span between column. We show that this is the maximum span between two columns. The maximum spacing between the column equal to 710. So the allowable unit, the maximum unit can we have equal to 700 times 10 to convert it to millimeter unit. Then we divide this spacing or this span over 240. So the allowable deflection equal to L over 240, where L is the maximum span between two columns and the plan. So the allowable deflection and this project for all stories equal approximate 30 millimeter equals 3 centimeter. So the allowable deflection this project equal approximate 30 millimeter equal to 3 centimeter. So we return now to safe. We have the allowable deflection equal to 3 centimeter equal to 30 millimeter. Now we want to show how much we have deflection in this slab. First of all, we began with the material. We check with the material. We go to define materials. ETABS export when we exporting the file from ETABS, the material that we have defined in ETABS will exporting here. So we check them. We go to mat1 and we press modify. We show that mat1 is the F'(C) 25. So we name it at F'(C) 25. We press OK. Mat2 is the T420. Just we change the name of the material because this material will have defined them and the ETABS, and we import them to save, and it's changed his name, so we will modify them. This is the H240 and this is the F'(C) 30. We don't need another material, so we have defined the material. We press then OK. Now we want to check the loads. Now we want to check the loads on this slab. We can select this slab and press right click and go to loads. So we check that the loads are right way, 3.5 kN per meter square and 5 for live load. We press then OK. Now to check the deflection of this slab, we want to define a 3 load cases. Then we want to do a combination between 3 load cases to and this step we will get us to find and calculate the deflection of this slab. We go return to the PowerPoint. We show that the first 3 load cases, the load case that we want to define is this. So we go to define load cases here. We press add new cases. These are steps to calculate the deflection, and we must know that we have a short time deflection and long time deflection. Short time deflection is to the self weight of the structure. Long term deflection is due to a shrinkage of the concrete when water go out from concrete, so we have a cracks, so we have a shrinkage. And from creep is the cracks of concrete due a critical or constant loads with time. So when concrete is tired, so we have creep. This is creep. So we want to define and tell safe this thing to define short-term and long-term deflection and check our deflection and this slab is equal to how much. So to do this thing, we want to do many steps. These steps allow us to calculate the deflection. First of all, we want to define the first load case. First load case, it's non-linear cracked with 1 dead load plus 1 live load. We can name it at what we want. Let's name it at deflection 1. We put here non-linear crack plus dead plus with 1 and live with 1. We press here OK. Then we press here add new cases again. We go to the second load cases. We name it at deflection 2. We go to the presentation. We put here non-linear, and here we have to define the creep coefficient and the shrinkage coefficient. when we put here creep coefficient equal to 2, this is the maximum coefficient for creep. And here when we put 0.305 for shrinkage strand, these are the maximum constant for shrinking. So we let the maximum shrinkage and maximum creep coefficients. We put here 1 and 0.25. 1 and 0.25. The last load cases, the last load case is we name it a deflection 3, non-linear and with dead load. So non-linear cracked with dead load 1 with 1 and live load with 0.25. Okay, we check this. Yes, so we press here OK. Now we press OK, then we go to define load combination. We add the new combination, then we put here deflection 1 plus 1 deflection 2 minus deflection 3, and this is the total deflection. So now we have, with this one combination, we will show the deflection, total deflection and the slab. So to calculate the deflection of the slab, we do these steps: define load case 1, load case 2, load case 3. I'll mention it in this PowerPoint, and we do a combination between 1, 2, 3, 1, 1, minus 1. We press OK, then OK. So we go to run. First we can show the slab thickness. We go to define slab properties. This is a waffle slab type 1. This are the parameters that we have defined and ETABS, F prime C, and this are the coefficient. We press OK, OK, and all thing is ready now to run. We can run the software, save it, and now the software save again to run and calculate. And we will remind that the allowable deflection and this project equal to 30 millimeter. So we need a deflection below 30 millimeters. So now save has finishing from run. We want to show how much equal to the deflection. To do this thing, first of all we can show undeformed shape, and also we can show the ribs as an ETABS. We check slab internal ribs. Okay, then to show the deflection we go to display, show deformed shape, then load combination, total deflection, we show the deflection, then we press apply. So it save tell us that we have a maximum minimum deflection equal to minus 13, and the allowable deflection equal minus 30. So we are below the allowable deflection, so this slab is safe with deflection and deflection. So this slab is safe under deflection. So also the same step we will apply them on all the type of slab. So we don't need to do every type of each type of slab. So we the same steps, the same load cases, and same combination. We apply them to show the deflection for other type and of slabs. Thank you for listening, and we will continue in the next session.